I'm going to take you through section 1.3 here, locating points and midpoints. Before we jump into that section, let's do a little review over 1.2, where we left off last time. Got 3 problems here, so go ahead and pause this video, see if you can answer this question. All right, let's look at it together. It says, what is the value of x and AB if B is between A and C? And then it gives you all this other information about the segments. So they don't have a picture drawn for you here. So the first thing I want you to do, if they don't draw you a picture, is I want you to draw a picture of this. Get a good visual here. So it's talking about, let's see, it says B is between A and C. So we're talking about a line segment here. Okay, think about what your endpoints are. B is between A and C. So our endpoints are A and C. Doesn't matter the order, right? We could have switched those, totally fine. Now when it says B is between the points, be careful here. It's not telling you that B is a midpoint. Like, it's not saying it's right in the middle, it's just saying it's somewhere in between the two. So just a helpful tip here, if they don't tell you that it's the midpoint, I would purposely draw that point off center so you don't get confused thinking it's right in the middle of them. Okay, that's going to be confusing later on. So I'm going to purposely draw that off center. I don't know exactly where it is. They don't tell us. So it could have been over here. It doesn't matter. We're just trying to get a visual. All right, from there, I would carefully just label everything. So it says, talks about AB being 3x plus 2. So let's label that. Here's segment AB. And then segment BC is 7. And then AC, so somehow label that all the way from A to C is 8x minus 1. Okay, after you have it labeled, think about how you could set up an equation here. We did an example like this in class last time, and we said how the whole is equal to the sum of the parts. So if I add segment AB to segment BC, I can set that equal to all of AC. All right, so let's do that. Let's add segment AB, which would be 3x plus 2. Add that to BC, which is 7, and I can set that equal to the whole thing, just using some logic here. It's called segment addition. All right, from here, it's just algebra. Go ahead and simplify this and solve for x. If you do, get x equals 2. Check your math there. We got some answer choices here, which that narrows it down. We know it's going to be this guy right here, but double check it. It wanted you to solve for AB. So in order to do that, take your x value 2, substitute that back in for x right here at segment AB. So we're doing 3 times 2, which is 6, plus 2, and that's how they get 8 for segment AB. All right, nice job, guys. If you got A, great job. Let's try another one. If you want to pause this, go ahead. Actually, we probably need to talk about a couple things here that you may not have seen, like this symbol right here. I had a lot of kids say, oh, that's approximately. It's actually not. You guys are thinking this one. If you thought approximately, that's the signal you're thinking of. So that's approximately. We know this is equals. This is something different. This is an equal sign with the little squiggly above it. Okay. New sign here. This is what we call congruent. Congruent, which is very similar to equals. There's just a subtle difference. Let me explain it. So if you look up here, it says if segment AB is congruent to segment BC. So think about that. 2 segments that are congruent. Okay, we don't say that they're equal because they are different segments. They're not the same segment. They're different ones. But what it's trying to tell you is that they have the same length. They have the same measurement. So if that's the case, they're going to say that the segments are congruent. Okay, so if segment AB is congruent to segment BC, AB equals this, BC equals that, find the length of AB. So what I want you to do here is draw a picture. Try to draw this as one line segment. Okay, so it says segment AB, so start off with that if you're not sure what to do. You got segment AB. Congruent to segment BC. You could do a whole separate line segment, but since they both have point B in common, we can just continue to extend this and create BC. All right, now this time I am going to have B right in the middle because it says that AC is congruent to BC. Notice I add these tick marks here to show that they are the same. You'll see that a lot in geometry, okay? So we do have B as the midpoint because these distances are the same. All right, you've probably figured out what to do from here. We could label each one. This is 4x minus 2. BC is 3x plus 3. Since they are congruent, you can straight up set those equal and solve for x. So we're not adding segments here and setting it equal to the whole thing because they don't give us an expression for all of AC. But we can set them equal. And if you do that, you should get x equals 5. But be careful. Don't go over here and circle this answer. Don't do it. Notice it says find the length of AB. Now you're almost there, but not all the way there yet. Okay, you just found the value of x. So take that, substitute that back in for x right here to find the length of AB. So you're doing 4 times 5 minus 2, which gives you 18. All right, nice job. Last one here that I want you to review, a little distance formula. You may have to look in your notes for that formula. So pause it here, see if you can get the answer. I'll go ahead and write this formula if you do not have it. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. So for these distance formula problems, I would always start with writing down the formula. Okay? From there, you can substitute things in and then just carefully simplify. All right, so substituting things in. So we've got x2 minus x1. Let's look at our x values, right? We could say this is our x1 and y1. This would be my x2 and y2. So substituting in for x2 minus x1 would be negative 8 minus negative 12. Remember, if you do minus and negative, you might as well just make that a plus sign. So let's do negative 8 plus 12 squared. Plus, substituting in here, y2 minus y1, we've got 3 minus 0, whole thing squared, and we are just carefully simplifying. Okay, from there we get, if we add these, we get 4. If we square that, we get 16. Over here, 3 minus 0 is just 3. 3 squared, we get 9. If we add those, we get the square root of 25, which is a perfect square. So our distance here would be 5. Great job if you got that. All right, that was basically a review of the stuff we did last time. Let's go ahead and jump into this last section here. So we're locating midpoints in this section. So we'll start looking at a number line, and then we'll look in the coordinate plane. I personally think this is a really easy section. I think you will agree. So if you want to go ahead and pause this and write down this formula for the midpoint on a number line, go ahead. I'm going to go ahead and explain it because it's very simple, very intuitive. So it's saying if you have two endpoints, A and B, to find the point right in between them, the midpoint, you simply add the endpoints and divide by 2. So think about that. That's just like finding a mean of two numbers, right? Finding an average. If I said, hey, find the average of these two numbers, you would add them together, divide by 2, and you'd get the number right in between them. Same with a midpoint. So if you look at this example, which you can go ahead and write in your notes, it says find the midpoint of BD. So pause this, write it down, and then we'll look at it together. Okay, so first of all, there's 4 points on this number line, so make sure you're looking at the correct ones. It says find the midpoint of BD, that segment. So we're talking endpoint B, endpoint D. Midpoint 2, right? Wrong, that's not it. A lot of people make that mistake. I tried to throw you off there. Okay, you've got to do the math here to verify the midpoint. Okay, so if we're doing the midpoint, I'll put M for midpoint equals. Remember, we're just going to follow our formula, which is our endpoint plus our other endpoint divided by 2. So let's see, we got negative 14 plus 22, all divided by 2. Simplifying that, negative 14 plus 22, we get 8. Divide by 2, so our midpoint is actually 4, not 2. It's a little bit over there, right in the middle. Awesome. Okay,